Hi. So I'm Chris Bailey. I work at IBM. I work on what we call Cloud Native Runtimes. So this is working on the languages themselves and their underlying runtime implementations, primarily for Java, Node.js, and Swift. So that's Apple's programming language for iOS devices, so iPhones, that we've brought to be able to run on the server and run inside the cloud. So as well as those programming languages, we also work on application frameworks on top of those, and generally libraries and capabilities to get them running in Docker and Kubernetes and so on in the cloud. So today we're going to talk about how people are increasingly using Node.js as well as Java. It's not a replacement. We see a lot of use cases where people are taking existing Java deployments that they've got and starting to add Node.js processes around it. So to talk about how Node is being used with Java, we kind of need to start to talk by saying how they're different and how the two of them compare. And we'll actually start with an article from Java World from a couple of years ago. But the story that they gave, I have seen probably every few years in my career working on Java. I actually started working on Java and JVMs 18 years ago. And that is, they said, developer trend number 2, Java's decline as a language will accelerate. So the statement was, Java is dead, which we've heard again and again and again, and yet Java is still, the biggest used language in enterprises. So what they said was, Java is in decline. Just look at the available jobs. The jobs that are there are just doing maintenance and support for existing applications. Look at the jobs for Node.js and things like Spark and MongoDB. That's where all the new development is. So Java World were making the statement that Java is dead, Node.js is growing. And they're not the only ones who've been kind of showing this information over the years. So take GitHub and the GitHub State of the Octaverse survey. So this is from this year, and it shows that certainly in terms of people doing pushes and commits to GitHub and the number of projects in GitHub based on language, JavaScript is number 1. It hasn't just been for the last 4 years, it has been for about 8, all bar 1 year. But Java is number 2, and that's also been the case for the last 8 or so years. One of the interesting things is it's not just that JavaScript is number 1, TypeScript is number 7. And for those who've never done any work with TypeScript, TypeScript is a pre-compiler for JavaScript. So it allows you to have typing. You write TypeScript code, it compiles down into JavaScript. So anybody doing TypeScript is actually fundamentally doing JavaScript as well. So you can almost add those two numbers together to see the size of the JavaScript ecosystem in GitHub. Now, some of this is kind of obvious if you think about the fact that JavaScript is not compiled, right? I cannot give you a JavaScript binary to use in your application. So because when I give you a JavaScript library, you're getting actual JavaScript code, you're getting the source, it increasingly has become in JavaScript that everyone does all of their projects in open source. So one of the reasons you see so many JavaScript projects in GitHub is there's a much wider open source community around JavaScript because anyone's delivering a module, it's done in source code. RedMonk, so these are a bunch of analysts who specialize in talking about programming languages and programming language adoption. This is their matrix of language adoption over the last 5 or 6 years. Number 1 is JavaScript, and number 2 is Java. So their results are very similar to GitHub, and part of that is because they used GitHub data inside their analysis. They also use Stack Overflow and a few other things. But their assessment, if we look at that in a bit more detail, is JavaScript is the number 1 language, Java is number 2. But again, that's kind of been true for the last 5 years or so. So why is it that people seem to be doing so much JavaScript? Well, it does start with developer productivity. So let's just look at Maven and Maven Central and look at how many packages are available for Java developers. So this is taken from modulecounts.com, which does an assessment of all of the available packages in open repositories over time. So this is the growth of packages available in Maven Central for use with Java applications. And it's grown over the last 5 or 6 years from a fairly small number, around 50,000, up to 240,000 or so. So there's a sizable number of packages, at least until you compare that to NPM, which is the Node package manager. And Node has been massively accelerating to the point that any time I present this chart, it's already out of date. They're adding something like 3,000 packages every single day, which is why there was actually a post on Twitter about a drinking game that is basically open the dictionary, choose any word, and if it's a JavaScript framework, you have to drink. So basically anything I want to do in JavaScript, there's going to be a package that does it because there's something like 730,000 of them available in Node Package Manager. So that means the amount of code I need to write myself is somewhat compressed. They've also made it very simple to build any basic application. So a lot of the reason why people get up and going very, very quickly with Node.js for server-side JavaScript is what it takes to actually write an HTTP server. So this is all the code that's required. You actually only need 6 lines of code. I declare a var, so all variables in JavaScript are just vars, there's no typing, and I require an HTTP module. HTTP is part of Node.js itself, so I don't need to do anything to install that. I ask it to create a server, and then I declare a function that should be called whenever requests are made of that server, and I tell it to listen on port 8080. And in fact, I don't actually need to write all of those 3 lines of code. I could have just done response.write, and it would have inferred the other 2 for me. But basically, I can get up and running and actually have a functioning website in 5 or 6 lines of code. And the other thing I can do is it comes with a module called cluster that is designed to deploy a cluster of them. So it will deploy multiple instances of my application on the same machine. So here I'm saying, for the number of CPUs that's available, so os.cpus.length, os.cpus is just an array of the CPUs on the machine. Length tells me how many CPUs there are. And I'm calling fork and creating a new process for each of those CPUs. And it also provides an event called death. So this is when one of those instances dies. Now, what I'm choosing here is to just print out and say one of those instances has died, but I could just make that do cluster.fork. So when one of them dies, it just restarts itself. So I've gone from kind of 5 lines of code to write an HTTP server to about 15, and I've written an on-machine cluster with auto restart if any of them fail. So Node.js has made it really easy to actually get up and get going. Now, the other thing that they've done is they've made it very easy for a developer to build a scalable application. So this is kind of the traditional way of doing Java I/O. So anyone that's used to creating an application server with a thread pool, this is kind of how it works. It's kind of like a parcel collection depot. So you know when like FedEx or the post office try and deliver a parcel, you're not at home, they give you a card and you have to go down to the depot. And what happens is you come in, you go to the counter and you give them the card. The person behind the counter looks at the card, goes off into the warehouse, and you're stuck there at the counter waiting for them to come back. And eventually, they come back and give you your parcel. Now, if there's any other customers that come in, they have to stand behind you in the queue waiting for you to finish. And the only way to scale is to have more depot workers. And that's why with traditional application servers, you have a thread pool, and you just increase the number of threads in the thread pool, and that's the number of concurrent requests you can handle. So it's basically depot workers are the equivalent of threads. And because they go off and do all of this work, all of the other users, all the other incoming requests are blocked, waiting for a response to happen. The model that's inbuilt to Node.js, and you can actually do this in Java through reactive programming frameworks like Netty, but this is what's built into Node.js out of the box. It's much more like a fast food restaurant. So in a fast food restaurant, you go up to the till and you make an order, and they give you a bit of paper, and they also take one of those bits of paper, they give it to the kitchen, and then they go off and serve the next customer. So they've delegated the actual cooking of your order to the kitchen, and they work on the next customer. So you can have multiple customers actually being serviced at the same time from one server because they've delegated all of the hard work to the kitchen to do. So you get to the point that that server can not just deal with multiple customers, the limit to the number of customers they can deal with is how fast they can run forwards and backwards between working on you, giving the order to the kitchen, when the kitchen says it's ready, delivering it to the customer. So they shuttle forwards and backwards as fast as possible, and they can deal with multiple customers. And this is kind of the Node model. Node actually has a single event loop which serves multiple requests, and that's your individual server. And it achieves 100% CPU by shuttling forwards and backwards and not actually doing a huge amount of work itself. The aim is to delegate the work to back-end services and to just fetch and ferry those data between the two. And if you want to scale out more, you need a second server. And that's why Node has the cluster module, because you can only use a single CPU with one instance of Node. So if you want to use multiple CPUs, you have multiple instances of the same application. Now, the side effects of this is there's no synchronization, there's no locking, there's no shared data structures. If I want to share data between requests, I put it in a back-end service like Redis, and that deals with the locking for me. So from a programmer's perspective, I don't have to worry about race conditions or multi-threading. It's just not part of the programming model. So this leads to an approach where everything in Node is event-based. So what I'm doing is the server.on calls at the bottom are events. So there's a connection event, there's a close event, there's a connect event. And I register a function that I want to have run when that event occurs. So this is kind of similar to lambdas in Java, where I can now have a lambda that I want to have run when the thing that's calling it happens. So it's all event-based. There is no ordering here. It's when a connection event occurs, that function at the top will be called. They do not execute in order, they execute based on events. So it's an entire event-based programming model. Now, one of the effects of this whole, there's a huge package ecosystem. So 730,000 packages means I don't need to write a lot of code myself. And the fact that I don't have things like typing, so everything's just a var, and I can declare anything as a var, means the amount of code it takes to write any application in Node is actually significantly less than it is in Java. So this is a bunch of benchmarks from the Computer Language Benchmarks game, who implement a set of computational benchmarks in a set of something like 30 different programming languages and compare them. And so to implement those in Node.js actually takes us significantly less code than it does for Java, and it's on average about half the code. Now, another advantage of Node.js is full stack development. So we have gone, in terms of browsers, from having static web pages where everything was declared in plain HTML to the point that we can now have a replacement for Microsoft Word. You can have data sheets and spreadsheets all running as rich web apps. And this can only happen because everyone is now using JavaScript in the browser, and every browser has support for JavaScript. So if you actually look at the data now, use of languages in the browser, JavaScript is around 95%. There's still some people doing Flash. Silverlight has pretty much disappeared. What you'll notice is there's no mention of applets. Right? This has now completely disappeared. Some of that through the security advisories from a few years ago, some of that from the fact that applets are now deprecated and are going to be removed anyway. So all of the programming in the browser is done in JavaScript. Now, writing JavaScript on the back end for your web app actually then becomes kind of a natural extension. If all of your front-end developers are writing JavaScript anyway, they can start to serve up their own application, and they can share code between client and server. And in fact, one of the things that you can do is server-side rendering. You can actually render some of the stuff that would happen in the browser ahead of time on the server and send it as part of the original request. And the effect of this is first-time paint for your application as measured inside Chrome is significantly lower if you're using server-side rendering. So we can only do this because we're running JavaScript on the server. Now, it's obviously not all positive for Node.js, right? Every language has its pros and cons. And one of the areas it falls down is around type safety. So let's just do a simple calculation of adding the number 5 and the number 3 together. All right, so in Java, we can do this as a static. We'll declare a function called add, which takes an int a and an int b and just prints out the two values. In JavaScript and Node, I can do the same thing. I declare a var, which is add. So functions in JavaScript are just variables. Everything's a variable in JavaScript. This has two values, a and b. And I'm going to print, so console.log just prints to the console, a plus b. So I'm doing exactly the same thing in both cases. So when I call it, in Java I have to have a main function and so on. In JavaScript I don't. This is one of the reasons why there's much less code. I'm going to set variable a to 5 and b to 3 because I'm going to add 5 and 3 together. And then I'm just going to call add. So in Java I have to use Java-C to compile it. And then I need to use Java to run it. In Node, it's JavaScript. There's no compile stage. I just run it directly. And as you expect, in both cases, I get the value 8, which is what I expect and what I wanted. So let's actually just change this slightly. And we'll change the number 5 to being a string containing 5. So in Java, I have to declare that as a string. The only way to do this in JavaScript is to put quotes around the number. And that's kind of the signifier that it's actually a string and not a number. So in Java, I run Java-C to compile it. And as you'd expect, I now get an incompatible type error at compile time, because I'm now trying to pass a string into a function that only takes ints. In Node, there's no compile step. I run it, and I get 53, which isn't what I expected. And it's because one of those variables happened to be a string, even though I thought I was going to be adding two numbers together. Now, if you think about the way you send data over the network in JSON, it doesn't take a big error to change a value from a number to a string. And therefore, I go from doing what I thought was maths to doing concatenation of strings. So if I was doing financial calculations, I might want the type safety of knowing that this cannot possibly happen. Whereas in JavaScript, actually anything that you put together with the plus operator will execute. You can add functions and strings together. You can add objects and numbers together. It actually works, and it's all defined inside the ECMAScript standard as to what should happen. I actually don't know, because you have to get quite far into the spec to find out. And there's a few more of these. So we've done 5 and 3 to get 8, and the string 5 and 3 to get 53. So what happens when you take 5 as a string and minus 3 from it? Well, it gives you 2, because it auto-converts the 5 to a number, minuses the 3 from it, and you get 2. So that kind of makes sense. If I take 5 and 4 and minus them, it does the same thing. It converts them to numbers before it does the minus. So what happens if I typo and I put 2 pluses in? So in Java, it wouldn't compile. In JavaScript, it just executes it. And it gives me 54, which is actually the behavior that I would probably have wanted, so that's OK. If I do hello plus world, that's hello world. That's concatenation. That's what I expect. Hello plus plus world, though. Well, that gives me hello, not a number. So because I've done a plus plus, it's trying to convert the world into a number, and it can't, so it says it's not a number. And then it converts not a number into a string, so it can concatenate the two. So I end up with hello Nan. I can typo again and have a plus and a minus. That gives me 5 minus 2 as a string. I can declare a variable as 3. I can say 5 minus 3 plus 3, and I get 5. That's probably what I expect. If I go 5 plus 3 minus 3 in the other way round, I get 50. So basically, for pluses, it will convert to string by default. For minuses, it will convert to number by default. So it's a whole lot of behavior that it just executes. The chances are it's not what I meant to do when I wrote the code. So you lose type safety when you move to JavaScript, but it actually makes developers more productive in that if you write good code, you can do it faster. So what about performance? So let's look at the plus operator still. And look what happens when I add A and B together in Java. So what I'm doing is I'm taking an int, and I'm taking an int, and I'm adding the two together, and the compiler knows they're both ints. So the side effect of this is it can just convert that into a single add instruction. So that single add instruction is just an add I, adds the two together, returns the result. So basically the whole thing takes a single instruction. Now in JavaScript, I've declared my function as taking parameters A and B, and I'm adding A and B together. But the compiler has no way of knowing that these are going to be integers. They just know they're variables, and variables could be anything in JavaScript. So the first thing it has to do is actually check the type of the thing that's been passed in. So it will check A first, wants to know whether it's a string or a number. If it's a string, it then has to look at the type of B and check to see whether that's a string or a number. If it's a string, it's going to concatenate them. If it's a number, it's going to concatenate them once it's converted the number to a string. Let's say the type of the first one is number. I check the second one to see whether it's a string or a number. If it's a string, I concatenate. If it's a number, I have to check to see whether it's a floating point or a normal number. And if it's a normal number, it's an add. If it's a floating point, it's a floating calculation. So it has to do a lot more work to be able to do the same thing. Now, there are optimizations inside the compiler for JavaScript. So once you've called a function from a certain line of code, it assumes the next time through the parameters are going to be of the same type. So it does optimize for that route through. But it always has to have a guard in there in case it turns out that that's not correct. So even once it's optimized, it's still going to be slightly slower doing calculations than Java can be, because Java knows these things are integers. So the side effect of that is if we go back to those benchmarks from the computer language benchmarks game, the ones where I only had to write 45% of the code for JavaScript, the side effect is where lower is better, Java is faster on every single one of those, bar one. And this is because they are computational benchmarks. They're basically just doing math. And because Java has all of the type information, it can do that math significantly faster than JavaScript can. So I can build my application faster in JavaScript, but it's probably going to run slower. Now, that's just simple math. What happens when we start to build web apps? So there's a set of benchmarks called Tech Empower, which compares web frameworks across a whole set of languages and a whole set of frameworks. They do some fairly simple tests. None of them are all that complicated. The first one is Json Serialization. So this is just responding with a JSON payload of message and hello world. So Java is significantly faster than JavaScript, even though JSON is JavaScript object notation. And that's because building JavaScript objects is really fairly computational. So we put that on a chart. Java is faster than JavaScript doing web responses for JSON. If we look at single query, so this takes a request, goes to a database, fetches a row, brings it back to the server, sends that back to the request. So it's just an extra step of I/O. When we do that, we still see that Java is faster than JavaScript, but not by as much. So we put that on the chart as well. The difference is a bit smaller. A third of the benchmarks they do is data updates. So this is a request comes into the server, it goes to the database, fetches some rows, then goes back to the database with a change, and then sends the response back to the server. So it's an extra couple of steps of I/O. And when we do this, we actually see that JavaScript is now slightly faster than Java. And part of that is to do with the way I/O works. In Java, if you were at the keynote that Mark Reinhold did last night, and he talked about value types, and how with one of the benchmarks he did, he showed that rather than generating kind of like 5 gigabytes worth of data, once moving to value types, you only generate about 4 megs worth of data, and it runs 5 times faster. JavaScript has a bit more of that. The way it works in networking, it doesn't have to go through the equivalent of the Java native interface, and that's done faster. So JavaScript is actually a little bit faster at I/O than Java is, and it's very easy for you to write highly I/O applications. So the side effect of this is if you're doing computational tasks, Not only is Java more safe for it because of typing, it's faster. If you're doing something that's hugely I/O but doesn't do any real work inside the process itself, JavaScript might actually be slightly faster at that. So how do I choose which language to use when and where? Well, the general policy, if you're doing microservices, and the whole idea of microservices is to do one thing and to do it well. So I'm going to now be building individual applications for individual tasks. So on that basis, if you've got a task that is computational, then Java is the natural fit for it. If I'm doing something that wants the ability of full stack development, so I'm serving up a web application, I might want to use JavaScript. So if we look at that, we said JavaScript tends to be far more productive, both because there's more packages and because I need to write less code. So if I'm doing simple tasks, maybe JavaScript is a faster way of doing that. We know that if it's a CPU-bound application, or it's doing computational work, then Java is definitely better at it. And anything where I really need that safety that my calculations are going to be correct, then I should be doing it in Java. So Node.js is great for high-performance I/O, for async programming, and particularly if I'm serving up JavaScript anyway and I want to do full-stack development. So I develop my web app and my web server in the same language. Java is great for higher processing workloads. The fact that you've got type safety, it's got a rich set of processing frameworks. I mean, it's no coincidence that things like Apache Lucene, Elasticsearch, Kafka, etc. are all written in Java. So when you put Node and Java together, you get kind of the benefits of both, as long as you're using them in the right places. And that means you can build highly performant, scalable web applications with transactional components which are being done in Java behind them, and you build those as self-contained microservices. Now, in terms of what that means for traditional architectures, so who's ever had to build one of these, a three-tier architecture with a Java EE application server with a database, right? So that's pretty much everyone. So what's kind of starting to happen is, and this is just the move to microservices, you had that big application tier, and that's now being kind of pushed back as a service tier. And the first thing that you can do if you want to build rich web applications is you can introduce Node.js in front of it. And this is now serving the web application. So no more servlets and JSPs. That's being done by the JavaScript development team that are doing the web app, are building their own backend for it. All of the stuff that you do in transactional workloads are exposed as a JAX-RS endpoint or something similar, and then that continues to carry on doing your business logic. As you start to bring in more services at the back end, you may then start to look at doing microservices for all of your back end logic. And there's actually a space for Node.js here as well. One of the things that Node.js is very, very good at is providing a thin layer gateway. So let's say you've got an existing service that's using SOAP. But in order to use it in microservices, you would much prefer it to have a REST API. Node is very good at acting as a smart proxy that takes a SOAP endpoint and wraps it as a REST gateway. There's actually a Node application that was released a couple of weeks ago that takes any REST API and converts it into a GraphQL API by providing a smart gateway for it. Now, on the front end, because you're serving up JavaScript in the browser, Node.js is the natural backend. What we're also seeing is that this front-end delivery tier is actually also starting to get broken apart. So there's a consultancy called ThoughtWorks who did some work originally for SoundCloud. And they came up with this idea that really your delivery tier should be specific to the application that you're serving up, because the requirements of front-end applications tend to be very different. Certainly they're different between a web app, which expects to have all of the web content served to the browser, and for mobile applications, where all of the UI and the framework is already in the mobile application, and they just want to fetch data. And in fact, they can store data on the client. So the requirements of the back end are very, very different. So they've talked about taking that delivery tier and actually breaking it apart into separate components. So there, you would still naturally use Node.js as the backend for all of your web workloads. But if you're doing a backend for Android, on Android, you're going to be developing in Java or maybe Kotlin. So you can have that same team owning their own backend that provides data to the Android device working in Java or Kotlin. And you can do the same thing for Swift on iOS. You can run Swift on the server, so the iOS development team can write their own backend. And this is called the backend for front-end pattern, which, as I said, came out of ThoughtWorks. Now, this whole approach is not theoretical. Netflix are one of the many companies which are actually doing it. So this is kind of what Netflix used to have. They had a huge web server that kind of did everything, and that was a Java process. At the time, because originally Netflix was a way of ordering DVDs, it wasn't a streaming service, they really did everything just in the browser. But as they expanded what they did, they had to add support for Android and iOS, but also PlayStation and Xbox and Roku TV boxes and so on. So they got to this point that they had multiple front ends. Each of them had different requirements, which sounds a lot like our backend for front-end pattern. And that's what they've done. So for TV boxes, they have a backend for front-end instance that is designed to work solely with those TV boxes. They do the same thing for iOS and for Android and Windows and laptops and so on. Now, on the device itself, they do hybrid apps, so there's JavaScript inside it. So what they've done is all of that delivery tier is running Node.js, and it's owned by the same team that owns the front-end device. Behind that, they have what they call a remote service gateway, which is also a Node.js process. And that's an implementation of Falcor, which is kind of like a GraphQL gateway. It's a way of exposing APIs. Now, behind that, everything is Java. And in fact, Netflix is somewhat famous for pioneering a whole lot of the approaches to doing Java-based microservices. So they actually did all of this right-hand side first, and then added the JavaScript Node.js front end at a later date. But under all of this, all of that front-end stuff is owned by UI engineering. So they own the Node.js layer and the JavaScript front ends using self-contained squads. And their focus is all about providing user-centric experience. So these Node.js layers for TV and iOS and Android, those are solely serving up the data and the experience that the front-end devices require. Then systems engineering owns all of the Java stuff at the back end, and these are providing highly scalable, reusable APIs, which some or all of the front ends may want to be able to use. And their focus is really about projecting the capabilities of their enterprise. So the back-end teams are exposing their business capabilities as APIs, and the front-end teams are looking at what's my user's experience, what do they want, and then which of those back-end services do I need to work with in order to expose that experience. So that's great, but how easy is it to actually build, manage, and coordinate multi-language microservices? If I'm only using Java, then I know how to do monitoring, and I know how to do logging, and I know how to do scaling, and I know how to tune garbage collection, and so on. So who has heard of the Eclipse microprofile effort and Jakarta EE and so on? Oh, that's a small number of people. OK. So microprofile is a new set of standards for about how to take a Java application and containerize it for Docker and potentially Kubernetes or Docker Swarm or Compose or anything else, and provide cloud native capabilities like metrics, monitoring, fault tolerance, configuration, and so on. Now, in the Node.js space, there is an equivalent to this. Effectively, rather than a standards body in Node.js, it actually provides a single implementation that the community collaborates on. But the aim is these are solving the same set of problems, and they're doing them in exactly the same way. So we actually collaborate between cloudnativejs.io and microprofile.io to make sure that the way that we build Node.js and Java microservices is consistent. So that means the way you do metrics is consistent, the way that logging is done is consistent. So all of the operational concerns are consistent between Node.js and Java, and this makes it a lot easier to have interoperable microservices. So in terms of what you get from cloudnativejs.io, it's a full website that provides a whole bunch of templates for things like Docker and Kubernetes, health check endpoints, open tracing so that you can track requests across multiple microservices, support for Prometheus in order to do metrics, and as I said, there's templates for Docker and Kubernetes that are built into the project. So it's effectively kind of a mirror of everything that comes inside the Eclipse microprofile effort, which is being adopted by a whole number of Java frameworks. So we've got to the point where Node is particularly being used in the front end tier, doing the delivery, particularly for JavaScript in the front end. It's also got a whole load of usages at the back end, particularly when you're providing a gateway to an existing service and giving it a REST endpoint or a GraphQL endpoint, or providing gateways. So there are implementations of API gateways for REST and REST repositories. There are GraphQL implementations and so on, and these are all inside Node.js. Java is still king for everything enterprise and business logic and transactions, and that's not going to go away. What's actually happening is it's really that front-end tier where you want to be able to develop and deliver user experience quickly that Node.js is coming into the picture. So finally, any questions? Yep. So the question is, with reactive programming coming into Java, do you think that's going to stop some of the adoption of Node.js because of its async programming style? Well, yes and no. I think the biggest use case for Node.js is full stack development with the browser anyway. So that's not going to go away. I think some of what it can do in terms of stream processing, so there's a number of companies that are using it for video streaming, and it has stream processing built in out of the box. Some of those workloads may well go to Java instead. But yes, I think it's still going to continue its growth, particularly because of the browser use case. Anything else? OK, then thank you.